colored pens. Let's see how we're doing with the idea of parallel, perpendicular, equations of lines. So, what's the equation that models Mill Road? Start with Extol, Dalton, John, and then Davis.
Y equals 4x minus 3.
Okay.
Y equals 4x minus 3.
So you two agree.
Y equals 4x
Minus.
4x minus 3.
Okay. So that was a little different, Davis.
Y equals 4x minus 30.
So we seem to have overwhelming support for that. Very good. Now rewrite that equation into standard form. So that was a 30-second activity. So part B, what'd you get? We'll start with Xiomara, Alexandra, and then Matthew. What'd you get?
4x minus y equals 30.
Okay.
Negative 4x plus y equals 30.
Okay. So that was a little different, Matthew.
4x minus y equals 30.
Okay. It is 4x minus y equals 30. Of course, there are many other possibilities. But Alexandra did a great job. She knew exactly what to do, and I'm not going to pick on her in any way, but she did make a mistake. Could someone explain what her mistake was? Those of you who are listening carefully. Sebastian? You say it a little bit louder? That's right. A can't be negative when you're putting something in standard form. And so, it was negative 4x plus y equals negative 30, and you had to multiply the whole thing by negative 1. Now, unfortunately, if you got part A wrong, then you got part B wrong, and sometimes that happens. But questions, comments, or anything on this scenario? Go ahead, Michaela. 1x for part B. Did you get part A correct? Okay. So from part A, how do we get to part B? So that's the big question is, I'm saying that this is a 30-second thing. Obviously, I've been doing this for a long time. So for me, it's 30 seconds. Maybe for you, it's not. But if you are really experienced, then it will be. How do we get from here to here? What's the first step? Someone lead me along. Fung and then Matthew.
Subtract 4x from each side.
Very good. Subtract 4x from each side. Then it will disappear from this side and jump over to the other. And so we get negative 4x plus y equals negative 30, which is what Alexandra said. But now Alexandra knows what she has to do. So Alexandra, what's that final step to get to here? Multiply by what?
By 1.
Well, multiplying by 1 is going to do nothing.
Oh, negative 1?
Yeah, you multiply the whole thing times negative 1. And that will flip all the signs, and that's how we will get to here. So for me, in my mind, A was the hard work, and B was just understanding that it's the same equation, just rewritten in a different form. Okay? And I was very specific about the word I used. I had one of your classmates ask me, is this still supposed to be perpendicular? This has really nothing to do with this question. It has to do with this question. That's why I use the word rewrite. Rewrite means take something that's written and change its form. Okay? That's different than writing something from scratch. Now, Michaela, I was a little confused about your question. Did I answer your question in that process? Yes? Okay, good. Are there other comments or questions on the warm-up? Okay, put the warm-up to the side. Today and tomorrow together represent the culmination or the end of a large number of concepts we've been studying. We've been leading up to this for quite a long time. In fact, if you refer to the back of the room, pretty much everything has been leading up to this right here. This is the true real-world application of all of this. If you are a scientist, an economist, an anthropologist, anyone who's trying to explore and understand our world, we do this collecting data and trying to find trends with things, patterns. For example, why one season do we have 5 or 6 or 7 hurricanes, and then another season we have none? And is there data that predicts when these hurricanes will happen? And is there patterns there that we can, once we figure out the pattern, could we then predict the future? That's truly the goal. Our economy, I'm sure, I know you're a young person and you don't have to deal with money that much, but the economy has been struggling for a very long time. Has it always been that way? So what makes this time different than others? Is there data out there that can show us what happened to bring us to this point? And this is how scientists, and I use the word scientist to represent anyone who studies our world. We tend to think of scientists as like a chemist. But that's not what I'm talking about. I'm talking about anybody who studies our world. You are a scientist because you've been asked in your tip to study the world. A very tiny little part of it, but you've been asked to do that. And you've been asked to collect data. So this is the part where we learn how to analyze that data and then use it to make predictions. We're going to do it in a very math classroom-like way. Today, we're going to look at some very basic examples. But then next time when I see you, we're going to start expanding that to more real-world scenarios. So, we need some language. First of all, what we're going to be looking for is called the best fitting line, or the line of best fit, sometimes just called a line of fit. The publisher uses these terms interchangeably. And so what we're trying to find is a single line that follows a trend. That's an important word, the trend of the data. The process is called linear regression. Now, I'm putting this term up, and I'm asking you to digest it, but beyond that, I'm actually not going to use this term very much. I'm not going to say, hey, okay, right now we're going to do linear regression. But you might see it in the textbook, you might see it on a quiz or a test, and I want you to be introduced to it. So it's the process of finding the best fitting line. Then, once we establish a best fitting line, then we're looking for trends. One example of a trend is a positive correlation. If we have a line with a positive slope, that's going to be a positive correlation. Likewise, if we have a line with negative slope, that's going to be a negative correlation. And that helps us predict what's going to happen next. Positive correlation will be sloping up and to the right. Negative correlation will be sloping down to the right. And then there's a third possibility. Relatively no correlation. So what if we explore a scenario, we get data, but there's no trend? Well, then maybe what you were exploring doesn't have any validity. For example, what if I wanted to find out if the students who wore blue had the best grades? So I start collecting data, and I go to every student in the school, and I find if they're wearing blue, and I check their grades. So my prediction is that students who wear blue have the highest grades. Do you think my prediction would hold true? Because I don't think grades really have any are not influenced in any way by the clothes that you wear. So I can say that that's what I want to study, and I can get data to support it. I can get Shannon's grades and see, okay, check her grades and check Zaymar's grades and Dalton's grades, and see if they're better than the students wearing black and tan and white. But if I took the averages, I'm sure I would find that there's actually no difference whatsoever. And so there's no correlation between wearing blue and getting good grades. Okay? So are there any questions about the terminology? Again, we're going to be using all these terms except for linear regression we won't use very much. Okay, so what's the process? Well, you actually already know the process except for one part. So here is the process. First thing we need to do is make a scatter plot. You learned how to make a scatter plot in the beginning of chapter 4. So we took care of that. You are an expert at making a scatter plot of data. In fact, I would feel comfortable saying you guys are level 8s and 9s, Jedi Knights and Jedi Masters of making scatter plots. Then, here's where it's different from what you've experienced in the past. Now you have to decide, does your scatter plot look like you can model it with a line? In other words, do all the data points seem to form something that looks like a line? If you decide yes, then we proceed. If you decide no, then we stop because we can't do anything. But let's assume the answer is yes. Now we're going to draw a line. Here's the interesting part. Everyone's can be totally different. Not totally different. Everyone's can be slightly different, and everyone can still be correct. We try to draw a line that fits the data. Here's one way to know. Approximately as many points will be above the line as below it. So that's a guide that we're going to use in a little while. And then here's where it becomes a tool for prediction. We then write an equation of the line. And we can then use that equation to predict the future. So we've spent this entire chapter learning how to do this right here. Writing an equation using 2 points. The points don't have to be actual data pairs, but they have to be on the line. And that's another thing we're going to talk about. We're going to use slope-intercept form a lot today, but you should be comfortable with all 3 forms. Okay? So, you may not have any idea what I'm talking about yet, but step 1, you already know how to do. Step 2, you may not have thought about before, but you'll see is not something difficult to do. Step 3, I'm going to show you how to pick the line. And step 4, we've spent an entire chapter learning how to do that. So the only thing new here is learning how to get a line to fit your data. Are there any questions so far? Okay, I'm going to put up example 1 in a moment. I have printed the graph for you and we'll just attach it at the end of class. You're going to be drawing on this graph. If I didn't do this, then you would have had to draw out the scatter plot, and that would have been a bit much for the first step. So, to learn how to pick the line, I've eliminated step number 1. Make a scatter plot of the data. For example 1, I am taking that step away. So here's example 1. So, draw a best fitting line for the scatter plot. Write an equation of your line. So everyone needs their pencil and their ruler. So, we want to draw a line that fits the data. So don't draw yours yet, because we need to have an understanding of how to do this. So first we need to decide, does it look like our data moves in a line? Well, since this is the first example you're seeing, maybe you don't realize. So let me fast forward for a moment, and then I'll come back to this. So don't write anything. So one of these doesn't look like a line. Which one doesn't look like a line? Dalton? Yeah, the bottom one doesn't look like a line. So again, yes, I know it doesn't look like a perfect line, but we're not talking about a perfect line. In fact, real-world data does not come out in perfect lines, ever. That's why we have to do this process. So now, we want to decide where our line should go. So I'm going to put up some proposals up here. Don't do anything yet. So what if I decide to take my ruler and draw a line like that? Do you think I did a good job of fitting the line to the data? Okay, give me a thumbs up if you say, yes, I did. Well, I mean, it's not terrible. What's the problem with it? Can anyone articulate or explain what's wrong with it? John?
The bottom one is clearly too much off.
The bottom one? What do you mean the bottom one? One comma negative 1. 1 comma negative 1 is all the way over here. Oh, this point here? So you're saying since I'm so far away from this point, that means that my line's not good. Okay, that's a very good argument. Okay, Dalton and then Caleb.
It's a positive correlation, so the points can't be below it.
Points can't be below it? Well, I know you're just learning, so you didn't know yet, but yeah, points can be below it. Here's the difference between positive and negative. Positive correlation means it's going to go like that. Negative correlation means it's going to go like that. Has nothing to do with the points being above or below. But I know you didn't know that yet, so that's okay. So Kayla, what else?
There's not nearly the same number as the points on top as there is on the bottom.
Okay, how many points are above the line? 3, yeah, it looks like there's 1, 2, 3. This is kind of only partially on. And what about below it? There's 1, and then this is kind of touching it. So if we say that these 3 points are touching the line, so that point's touching the line, that point's touching the line, that one is, then I've got 3 above it and only 1 below it, and that doesn't meet the basic guideline of drawing a line. Here's the question. Here's the simplest thing. Is there a better line?
Yes.
Yeah, there's a better line, so let me try again. And so here's where you have to be careful with your ruler and don't draw your line right away. So what about this one? What if I do it like that? I got 2 of the points. 1, 2, right on the line. Isn't that nice?
Yeah.
But clearly, as John was trying to describe with this one, I've neglected all of this data here. And this clearly does not predict what's going to happen next. I mean, if I was trying to predict this is 1, 2, 3, 4, 5. If I was trying to predict what was going to happen at 5, it would be somewhere around here. Clearly, this is nowhere near the prediction. Okay, so that will not work. Here's another example of something I could do. That's pretty beautiful. I crossed 3 points. 1, 2, 3. That's pretty nice. What's the problem with it? Edgar? Yeah, there's no points above, and there's 4 points below. So I've got to try and find a way to get this line to fit properly. So I also want to make my life somewhat reasonable. So now you can pick up your ruler and let's see if we can fit a line somewhere through the middle. We want to try and cross some data points if we can, but if we can't, we can't. So it looks like right through the middle might be the best line of fit, something like that. Maybe something around there. So it's not perfect. I think I could have done a little bit better. Let me try one more time. So I've done a decent job. It's, again, not perfect, but it's pretty good. And the line is going to go on forever, so I'll put arrows on either end. So now I've got my line of fit, my best fitting line. Now I'm going to write the equation of the line. And so now I'm making the choices. So all through 5.1 to 5.5, I gave you the points, and I said, write an equation from this. Now I'm saying we have to find points to use, and then we're going to write an equation from it. So we need 2 points that are on our line. We need 2 points that are on the line. They don't have to be data points. These are the data points. But I could choose this point right here if I wanted to. I could choose this point right here. I could choose this point right here. I can choose any point that I want as long as it's on the line. So what points do you think we could use? Sebastian? So it looks like 3, 3. I'm pretty close to it. Right about there. So that's good enough. So we'll say 3, 3 will be 1 point that we're going to use. What's another point that we can use that's on the line? Michaela? 1, 1. 1, 1 is right there. Doesn't seem. 1, 2. Yeah, I'm pretty close to that one. I'm pretty close to that one. I'm a little bit above it, but I'm pretty close. Is there another? We could use that one. Is there another one we could use? Janae, is there another point we could use? That's on the line. That's easy to see. I know it's a little hard to see up here, but you can look on yours. Yours is the same thing as mine.
2.
Good. So that was what Michaela had said, 1, 2. So we're in agreement that this might be another good point, although it's a little bit off. There might be one that's better. Shannon?
-1.5.
This point right here? Yeah, I think that's a pretty good one. -1.5, comma, 1 might be a good one. But Janae, you were right, and so was Michaela. We could have used this one. I also want to try and pick points that are kind of on opposite ends of my line. So, want to try and get a point from way up here and try and get a point from down here. Okay? Yes? Okay, so now we have 2 points. Now we can write an equation of the line. We're going to use slope-intercept form. And so, we need our slope. We need our y-intercept, and then we can write our equation of a line. We'll know if our y-intercept is right because we can see it right there. We just don't know exactly where that is. It's a little too far. Like the middle, this would be 1.5. That's 1, that's 2. It's hard to tell where that is. But it'll be interesting to see if we get close to it. So how can we find the slope? See every single hand up in the room because everyone should feel super confident with this. Kayla? That was beautifully said. x1, y1, x2, y2. So we get the slope equals 1 minus 3 over negative 1.5 minus 3. Remember, this is real-world data, so we can use decimals. So we end up with negative 2 over negative 4.5. Negative over negative means it's positive, and we already knew that, like Dalton said, this is a positive slope. And so when we divide those, what do we get? What's our slope actually become? Pick up your calculator. And what do we get? Danielle, you ready? I'm sorry, am I going too fast? I seem like I just totally lost everybody. We now need to divide 2 divided by 4.5 so that we can get a value for slope, and then that's when you pick up your calculator and you punch it in. Okay, Stephanie? Yes, from your neighbors over there. I'll help you in a moment individually. Okay, Exol? 0.4 repeating, what'd you get? 0.4 repeating? Okay, so that's a tough one to write out. So we'll approximate it. We'll say 0.44 will be a good approximation of 0.4 repeating. The other thing we could do is leave this in fraction form, multiply the top and the bottom by 2 and get 4/9. Could do that too, either way. So now we need the y-intercept. So we have the slope, we have a point. Let's get the y-intercept. So we plug everything into y equals mx plus b. We've been doing this for a while now. Y, we can use this point because it's nice and easy. Y is 3. The slope is 0.44. X is 3. And let's see what that comes out to. I'll do it along with you with my calculator. 0.44 times 3, 1.32. So I get 3 equals 1.32 plus b. So what does b equal?
Yeah.
What does b come out to? Dalton?
1.68.
Comes out to 1.68. Now let's see, does that seem to be right? Does that seem to be that spot right there? I think that's pretty darn good. That's actually pretty amazing that it came out so accurate. And so now we have our slope, now we have our y-intercept, now we are ready to write the equation of the line. Y equals 0.44x plus 1.68, and that is an equation of our best fitting line. Does anyone have any questions about this process? And before you ask, let me just clarify what we did. We were given a scatter plot and we drew a line. We tried to get a good line that had as many points above as below. And then we chose 2 points from the line that were on the line so that we could then calculate the slope and find the y-intercept. Once we had those 2 pieces of information, we wrote out our equation of a line. Does anyone have any questions about that? Concerns? So now I'm going to add in the one step that I didn't make you do, which is constructing a scatter plot. So now, example 2. So this time, we're going to construct the scatter plot, then we're going to do everything we just did. Okay, so to save time and to try and focus on the concept of coming up with the best fitting line, I eliminated this step in the first example. Now I'm putting it in, and from now on, this is what we will do. Construct a scatter plot. So we need a full grid because our data points, some are negative, some are positive. And so now we need to plot all the data points. Our graph paper and our grids are going by ones, so we're going to have to do some basic estimation. So negative 3.2, negative 9.5. We know approximately where they'll be. So negative 3 is right here. Negative 3.2 is going to be a little bit past that. And negative 9 is down here. Negative 9.5 is going to be halfway. So now I'm going to go out to about right there, and I'm going to draw a point. And so I took care of that data pair. And then negative 2.5, negative 8.2. Negative 2.5 is here. Negative 8 is here. Negative 8.2 is going to be a little bit below that, somewhere about right there. So I'm just going ordered pair by ordered pair. Negative 1.8 is going to be a little bit before the negative 2. Negative 6.5, here's negative 6. Negative 6.5 will be about halfway. .5, so here's 1, 0.5 is going to be halfway. Negative 1.9 is going to be very close to the negative 2, so about right there. And I'm just continuing in this fashion. 1.3, negative 0.6, so it's going to be about there. And then 2.4, 1.7. Does anyone have any questions on how he's constructed the scatter plot? Now we need a line of best fit. So now we have to try, and you can use your ruler to kind of experiment and see where you want the line to be. The data definitely seems to be moving in a line. I mean, it almost looks like a perfect line, but I won't be able to tell until I put the line down. So it looks like it's going pretty nicely straight up like that. I don't think I did a very good job, so I'm going to back up and try again. It seems to pretty clearly be moving in a pretty good line. Does anyone have any questions on how we got to this point? I don't know about you, but I was able to draw almost a perfect line. It looks like one data point wasn't perfect. And since that's the case, we're going to calculate the slope. We're going to use the first point and the last point to calculate our slope, because I was able to get both of these points exactly on the line. So this can be my x1, y1. This will be my x2, y2. And I can calculate my slope from those. So I've got 1.7 minus negative 9.5 over 2.4 minus negative 3.2. I'll definitely need my calculator to help me along. So I got 11.2 on top. And on the bottom, I've got 5.6. And so 11.2 divided by 5.6. Wow, it actually came out perfect. So the slope is actually 2. Do we have a good idea of where our y-intercept is? Anyone make a prediction about when we calculate it, where it's going to land, the y-intercept? Davis? -3. It looks like it's going right through -3. My line looks like it might have missed it a little bit, but let's find out how close I came. Let's make our lives easier, and let's use this point right here since it's all positive, and now we know that the slope is 2. And so we can calculate the y-intercept. Y equals mx plus b. We've got a y of 1.7. Slope is 2. X is 2.4 plus b. Let's see what it comes out to. It's going to be 4.8. Comes out to negative what?
3.1.
Comes out to negative 3.1. Which actually looks pretty perfect right there. And so now we can write the equation of our line, y equals 2x minus 3.1. And now we have a tool to make predictions for the future. The part about predicting the future, that's what we're going to study next time when we see each other. So, comments, questions on how we did this? Go ahead, Matthew.
Find the slope. Do you pick a number up to 9 or 1 points?
It has to be on the line. So, for example, let me go back to this. If I were to calculate the slope, but I use this point and this point right there, that would be a problem, because that's basically saying calculate the slope of a different line. If I use those 2 points, then I'm really calculating the slope of this line. Oh, I didn't do a very good job of that. Let me try that again. If I do slope from here to here, that's a different line, right? So I have to pick points that are on the line. So that's why here we actually use this point and that point up there, because they're actually on the line. Even though this point and this point was part of the set of data. Doesn't matter. Once you establish your line, from that point forth, everything has to do with the line itself. Okay? So Matthew, that was an excellent question and a really important one. So I hope everyone else was listening. The difference in this one was that almost all of our data actually formed a nearly perfect line. Even though it didn't look like it was going to, it formed a near perfect line. Okay? Good. We're doing very well so far. I do not need you to draw these. Now we need to just have a discussion so you can put your pencils down. We need to understand the concept of positive correlation, negative correlation, or no correlation. And it's quite simple. If the data seems to move up and to the right, then it's going to be a positive correlation. It's a way of saying a relationship. So, this is clearly moving up and to the right. That is a positive correlation. If it's moving down and to the right, that's a negative correlation. The third possibility is, what if there's no correlation at all? There's no relationship. There's no pattern in the data, then there's no correlation. So you will be asked to decide what type of correlation, and you're going to have to write positive correlation, negative correlation, or relatively no correlation. You can use abbreviations. You can use POS and NEG. Okay? Does anyone have any questions on determining correlations? Michaela?
For the no correlation, how do we write an equation?
You can't. We can only write an equation that is for something that actually has a relationship. So remember the example I made up of students wearing blue and getting good grades? We can't write an equation for that because there is no equation for that. Because there's no relationship. So, draw a line across your paper, your classwork. It's on page 54. You're doing numbers 11, 8, 4, 3, and 1. The majority of the work will be in 11, 8, and 4. Or I should say the majority of the time, not the work. All right. Pick up your colored pens. Let's see how we're doing with fitting a line to data. Number 11. Here's what your work should have looked like. Here's the scatter plot. It says describe the correlation. It's positive. In this question, you were not actually asked to draw a line of fit. However, to answer part C, a line of fit would have helped a lot. So the answer to part C is no. There's a number of different ways you could have done it. You could have drawn a line of fit and then used that ordered pair to see if it falls on the line. You could have written an equation of the line and then plugged these coordinates into your equation to see if it comes out true. So you had some choices, and we'll talk more about that in a moment. Next question. Oh, let me move this up a bit more. Now, these are sample answers. So now you're going to have to use your mature, advanced brain to determine whether or not you got it right. Now, for number 8, the y-intercept is clearly -1. So you should have had -1 as the y-intercept, but the slope could have been different. So it should be close to 3/2. But yours might be a little bit different. So what is your slope? What's your slope, Dalton? 1? I'll take it. That's fine. What's 3/2 equal to? Okay. What's your slope? Andrew, what was your slope? 2. Okay, Danielle? 1. Okay. So if your slope was 1, that means this was your line. If your slope was 1, this was your line. Straight through those points. And that's okay. But these points, then this point and this point over here are pretty far away from the line. But that's okay. We didn't really talk about something being far away from the line. So that's pretty good. Okay? If yours was 2, that means you went from here up to here, I think. What else? What other slopes did we get? Anyone have anything different? Kayla? I'm sorry? For number 8? Can't be negative. A negative slope means that the line's going the other direction. Negative slope means it's going down this way, so you must have made a miscalculation somewhere. John? 5/4 is very close. Excellent. Anyone else? Michaela, what was your slope? 1. What was yours? It wasn't optional. Fang, what was your slope? Okay. Number 4, same thing. Slope had to be negative. Y-intercept is clearly 1. It's right there. You can see it. So it should be anywhere near -1.5. -3/2 or -1.5. And the last 2 questions. Number 3 was a negative correlation, and number 1 was relatively no correlation. All right, comments or questions on any of these? Okay, draw a line across your paper. Your homework is page 334, numbers 4 through 22 even. That's 10 questions. And you're going to read the next section. And then your test on chapter 5 is next week.